Good evening to all. Let us start with the today's live session, the seventh live session for the payment materials. In today's live session, we will be discussing the previous assignment questions. In addition to that, we will discuss the summary of the week 7 and also few numericals related to the week 7 will be discussed. If we see the first question in the week 6 assignment questions, the representation of compliance for a dashboard is equal to. So, if we see, we know that for dashboard, stress at any time equal to viscosity into strain rate. So, this we can write as d sigma by dt at any given instantaneous stress, viscosity equal to d epsilon by dt, which we can write as sigma t into eta into epsilon. So here they are asking about the compliance. Compliance is nothing but strain by stress. So here if you want to find out strain by stress, it will be T by eta. So here T by eta is the option B. Option B is the correct answer. And if we see the second question, in a nonlinear viscoelastic material, the response to any loading is a function of. So if we consider the linear viscoelastic material, its response is a function of time and temperature. In addition to that, if the response of the material is a function of amplitude of load also, then we call it as nonlinear viscoelastic material. So the option C is the correct answer. In a rheological model comprising of parallel arrangement of spring and dashboard, so they have given the following options. It is mentioned that the spring and the dashboard both are in parallel. So what will happen when two elements are in parallel? Let us say I have applied the stress sigma. When I applied the stress sigma, the amount of strain developed in each element will be same. So I am trying to pull here. So when I am trying to pull here, the amount of strain developed in the spring and also dashboard will be same. Whereas the amount of stress, if I wanted to find out the total stress, it would be sum of the stress in the spring and also the stress in the dashboard. So if you see the option B, total stress is the summation of stress in both the elements, and also the option C, strain in each element is equal. So these two are the correct answers. As per PG grading system, the minimum failure strain in a direct tensile test should be. So if you see the direct tensile test, yes, is there any question? Yes, you can unmute and ask.
हेलो मैम। हेलो मैम।
Yeah, you are audible.
मैम पेमेंट मटेरियल एनटीपीएल का पेमेंट का डेट था 28 अगस्त। हम पेमेंट नहीं कर पाए, क्या अभी कर पाएंगे?
Yeah. Please write a mail to the NPTEL team. They will respond to you. If there is a chance.
वहाँ पे नहीं हो पा रहा है।
Okay, I will share the NPTEL mail ID in the chat box at the end of the class. You can check.
मैम मेल बहुत किए हैं, उधर से कुछ रिस्पांस नहीं दे रहा है।
Okay, I will find a contact number. Then we can try to contact. So as per PG grading system, the minimum failure strain in a direct tensile strength test should be. So usually we perform this direct tensile strength test for very stiff materials who has the strain tolerance. So we recommend to use minimum 1% of tolerance. So the option A. And in the fifth question, reduced frequency is equal to. So if you take the master curve, where on the x-axis we will be having reduced frequency and the y-axis either stiffness or any other parameter. So how do we arrive this reduced frequency is what the question is. So if we have the frequency, we determine the shift factor and we multiply the frequency with the shift factor and we calculate this reduced frequency. So the correct answer is the option C. The sixth question is Kolkol plot is the relationship between. So this Kolkol plot is the relation between loss modulus and storage modulus, which is G double prime and G prime. So the option D is the correct answer. At the crossover frequency, which relation will be solved? So if you see here, the phase angle, when the phase angle is 45 degrees, let us say this is what, when the phase angle is 0 degrees, we call the material as elastic. When the phase angle is 90 degrees, we call the material as viscous in nature. So at some particular angle, let us say at 45 degrees, the loss modulus G prime and also the storage modulus loss modulus G double prime and the storage modulus G prime will be equal. That frequency, that corresponding frequency is called as the crossover frequency. So here the option is A. Penetration ratio is equal to. So we usually perform the binder test, which is penetration test at 25 degrees. But if we wanted to understand the temperature susceptibility of the binder, so we perform the test at other temperature, which is nothing but the 4 degrees. Penetration at 4 degrees and also we perform the penetration at 25 degrees. Then if we consider the stiffness of the material at 4 degrees and the stiffness of the material as 25 degrees, how much is the variation as we change the temperature from 4 degrees to 25 degrees? This represents the susceptibility, temperature susceptibility of the material. Thereby, if we see the option B, where the penetration at 4 degrees to the penetration at 25 degrees, this ratio usually indicates the temperature susceptibility of the binder. This we call it as penetration ratio. So for a PG64 minus 12 grade bitumen, what should be the intermediate temperature for testing fatigue characteristics? So if you understand at what temperature we are supposed to test the binder for fatigue characterization. So let us say here they have given PG64 minus 12. The code recommends that, the performance graded system recommends that if we have the upper maximum temperature and also the minimum temperature, here the maximum temperature is 64 degrees and the minimum temperature is minus 12 degrees. Let us take the average of these two temperatures and to that average temperature 4 degrees extra is what the intermediate temperature or fatigue characterization temperature. So here that would be 64 minus 12 divided by 2. This is the average plus 4 degrees. 64 minus 12 would be 52 divided by 2 plus 4. So 26 plus 4, which is 30 degrees. Thereby, if your upper PG temperature is 64 degrees and the lower temperature at which we need to determine the lower temperature properties is minus 12, then we have to perform the fatigue test at 30 degrees. So the answer is 30. If the minimum temperature of a project location is minus 22 degrees, the BBR test should be done at a temperature of. So it is mentioned that the project location is having a temperature of minus 22 degrees. This bending beam rheometer test we perform to understand the properties of the binder at lower temperature. So usually to understand this bending beam geometer test properties and to perform the test at the project location, we are supposed to perform the test for 2 hours. But for the sake of usability, what we have done was, let us say if I want to perform this 2 hours of test only for 240 seconds, then I need to change the temperature, because we know that time and temperature interchangeably can be used. So at that case, if the project location has a temperature of 22 degrees, let us increase the 10 degrees, then perform the test for 240 seconds only. So when I increase the temperature of minus 22 to 10 degrees, that would give us minus 12 degrees. Therefore, the option is minus 12 degrees. So let us see the summary of last week. So in this week, we have mostly discussed about the modified bitumens and what is the purpose of even having a modified bitumens. Why do we even need to go for modified bitumens? And types of bitumens, which is the emulsion bitumen, and also the a very brief discussion on cutback bitumen is also being discussed. In addition to that, the introduction of bituminous mixtures and the process of preparing the mixed design has been discussed, and the following details regarding the mixed design, which are volumetrics, will be discussed in the upcoming week. So let us start with the modified bitumen. So why do we need the modified bitumen? So we already have the conventional bitumen. We already have the conventional bitumen. This conventional bitumen, which is like VG30, VG40, which we use. So when we have been using this conventional bitumens from previous years, what we have understood that when the axial load spectrum has been changed or the traffic loads has been increased, the pavement couldn't able to take the stresses which are generated by these heavier traffic loads, and also with changing environmental temperature and also the moisture damages. Thereby, in order to compensate these failures in the payments, we are supposed to modify the bitumen. So, in doing so, the base bitumen, which is already the existing bitumen, will be added with some other chemical agents. Thereby, the base bitumen's either chemical or physical structure will be altered. So, when its structure is altered, it improves its mechanical properties like strength properties. So, where do we usually use this modified bitumens? Wherever the places which are extreme conditions like higher rainfalls and also the more temperature variations. And also when we have the increase in vehicular loadings and higher tire pressures, which can cause higher stresses on the pavement surface. Wherever there are new axial configurations that are introduced, thereby these axial configurations would be giving higher stresses on the pavement surface. Thereby there is a more possibility for the failures, and also to reduce the frequency of maintenance. So let us say if we use the base binder or unmodified binder, it also might take all these vehicular loadings, that higher tire pressures and the new axial configurations, but we might need to do the maintenance in frequent manner. If we ever wanted to avoid that frequent maintenance, then we might need to go for modified bitumens. And also in addition to that, if we generally have the payments with the thickness of H1 and we do not want to proceed the payment construction with those higher thicknesses, and if I want to reduce the thickness in future constructions, so to use the thinner layers also we can go for modified bitumen. Only one of the thing is the cost of the modified bitumen would be higher than the unmodified bitumen, whereas this cost to benefit ratio compared to the unmodified bitumens, if the maintenance cost is compromised or it is reduced, it is always better to use the modified bitumen. So this contribution of modifiers is, let us say the pavement will not be subjected to only higher temperatures or only lower temperatures. So it would be subjected to variation in temperatures. So this temperature performance can be improved, especially at higher temperatures, without affecting the performance at other temperatures. So the stiffness and also elastic component increases. The main difference between the unmodified and modified binders is when the load or tire pressure is applied on the bitumen, unmodified binders have the tendency to not recover. Even though if you try to provide a lot of time after the removal of the load, still they couldn't able to recover. Whereas for modified binders, they could able to recover, thereby we can reduce the permanent deformation or plastic strain in the pavement surface. So there are various types of modifiers available to improve the performance of unmodified binders. Polymers are the most widely used modifiers. So these modifiers usually should be easily available and they should be at lower in cost and they should blend easily. So already the existing unmodified or conventional bitumen has the certain it has certain chemical composition which we already know, that is Sara fraction, saturates aromatics, resins and asphaltenes. So in addition to that, we are going to add some other chemical agents. So the existing bitumen should be able to blend easily and these chemical agents or modifiers should not be separated very easily and they should not degrade at higher temperatures. Every time when we are going to mix the binder with the aggregates while preparing the mix designs, we tend to heat the binder at higher temperatures. So when I use the polymers to prepare the modified binders, these polymers should not degrade at these higher temperatures. They should be stable. So if I store my modified binders in a container and if I come in the tomorrow and see, these polymers should not get settled at the bottom and base bitumen should not be settled at the top. So they should not be separated. Then the effectiveness of the polymers will not be utilized. During the storage and also during the transportation and laying also, polymers should not be separated. So it should improve the resistance of the bitumen to distresses. Whenever we talk about distresses, the main distresses are rutting, fatigue and lower temperatures. So at varying temperatures. So let us say I have started adding this polymer so that I wanted to modify the existing bitumen. So what is the main problem is the existing bitumen, which is unmodified bitumen, we know that it already has asphaltenes and also maltines. So let us say maltines is a liquid in which asphaltenes are being dispersed. So the amount of maltines to the asphaltenes ratio defines the dispersion of asphaltenes. If we do not have proper amount of maltines, the asphaltenes cannot disperse in the appropriate manner in the bitumen. So in addition to that, if I add some polymers, then what happens? This maltine phase is again affected by the polymers because now these polymers also has to be dispersed in the same maltine amount. In addition to that, asphaltenes also should be dispersed. So addition of polymers usually disturbs the equilibrium of base bitumen. So what should we do? So the chemical structure of the base bitumen needs to be understand. So what is the amount of ratio of maltines and asphaltenes fractions that needs to be understand, and also the molecular weight of polymer that we are going to add and the type and concentration. So how much amount I should add the polymer so that it should not disturb the dispersing property of the asphaltenes, and what is the structure of the polymer? Is it going to affect the existing structure of the base bitumen or is it going to affect the stability of the base bitumen, and also the presence of cross-linking agents such as sulfur. So as I have informed, when I start adding this polymer, it will actually affect the dispersing properties or dispersing state of the asphaltene. To avoid that, we might use some of the cross-linking agents like sulfur. What happens when I use the cross-linking agents? Let us say we have polymers. We already have base bitumen. So to this base bitumen, I have added polymer to improve the properties. So while adding this, let us add some sulfur. So when I add sulfur, what happens is initial base bitumen and the sulfur, they both will react and this will form some sulfides, specifically polysulfides. So what is the purpose of these polysulfides is, these polysulfides actually they form, let us say this is a polymer. So around this polymer, let us say SBS is the polymer I am using. Around this polymer, it will form a cover kind of structure. So thereby it will not be affecting the dispersing stability of the asphaltenes. So sometimes it is required to use the cross-linking agent so that it will not disturb the stability of the base bitumen. And also in addition to that, when we are adding the polymer, we need to understand initially there is a complete bitumen. I have started adding little polymer. So here it is bitumen rich. As I keep on adding the polymer, the bitumen will be converted into polymer rich. So there will be a stage where polymer will be more and bitumen will be less. So we need to come to an optimum stage where bitumen and polymer should be in the optimum doses so that the stability of the polymers and also the asphaltenes in the binder will be stable. So let us say I have added the polymers and I have created this polymer modified bitumen. How can we directly use that? So what are the tests to be performed before using this polymer modified bitumen? So the traditional test which we perform on the base binders, all those tests needs to be performed. In addition to that, there are some special tests. These special tests are to understand the storage stability of the modified bitumen. So when I added the polymers into the base binder, whether they could be able to be stable when I store, otherwise are they going to separate into the two different phases. To understand that behavior, storage stability test, and in addition to that, elastic recovery test. The main purpose of using these polymers is to improve the elastic recovery of the binder. So unmodified binders cannot recover, whereas modified binders can recover if the sufficient amount of time is provided. So this benefit can lead to when we have higher vehicular stresses which are applying more stresses to the pavement surface. If you provide the recovery period, even though there was a strain in the initial stages, after a particular amount of time when we have used these modified binders, it can be recovered. So what is that amount of elastic recovery that is being produced because of adding the polymers? And also the multiple stress creep and recovery. In addition to this elastic recovery, to understand the effect of load on the modified bitumen, and also the in addition to that, so when I keep adding the stresses, let us say 0.1 kilopascals is 0.1 kilopascals is a lowest stress level, 3.2 kilopascals is a highest stress level. When I keep applying these two stresses on the modified bitumen, what is the response of that bitumen? And when I provide some recovery in between these stresses, how much is the amount of the deformation that is getting recovered? So these responses can be understood from the multiple stress creep and recovery. So these are the three major tests. So to understand the storage stability, so the basic thing is, let us say we have the bitumen. In this we have bitumen plus polymer. Now I will heat this. So what happens? Bitumen and polymer will be mixed homogeneously. Now I will heat this at and I will keep this solution around 163 degrees for 48 hours. So after 48 hours, what happens? Now these polymers are completely mixed in this base binder. So immediately I will freeze this in a freezer, and after few hours what I would be doing is, this container which is having the modified bitumen will be freezed. Then I can actually cut them into pieces. The top one will be piece 1, middle one will be piece 2, the bottom one will be piece 3. If at all there is a separation of polymer from this modified bitumen, either that polymer could have come to the bottom or it could have gone to the top. So there is a possibility of separation if it is moved from either sides. So how do we understand whether it has separated or not? After cutting this, we will take the portion 1 separately, we will take the portion 3 separately, and we will perform the softening point test on the portion 1 amount and portion 3 amount. If the softening point of portion 1 is 55 degrees, and if the softening point of portion 3 is, let us say, 60 degrees, that means there is a difference in the softening point between portion 1 and 3. It is a difference of 6 degrees. That means one part has become more stiffer, other part is less stiffer. That means that few amounts of polymers could have shifted to one side. If not, what could have been happened? The stiffness or the softening points of any location could have been the same, or it should be less than 3 degrees. But it has been more than 3 degrees in difference, which implies there is no stability of this modified bitumen. And in addition to that, just like in the ductility test, so we have already discussed about the ductility test. So we have a briquette mode, so in which bitumen we pour like this, and we try to apply the load 5 centimeters per minute. We see that this bitumen keep on stretches and it will break at some time. That is the ductility test. Here in the elastic recovery test, exactly in the same way, we try to stretch this bitumen to a distance of 10 centimeters. After stretching to the 10 centimeters, I will cut it in the middle. So after cutting in the middle, what happens? This part, it will move this side. This part, it will move this side. So if I wait for some time and see, there will be a gap formed. It will be like this, it will be like this, because now I have cut. If we wait for further time, what happens again? This will again come back, this will again move back. So this gap, if you see, it will keep on increases. So again, this is the place we have actually cut the sample. So from here we will bring back the material to here, and we will see how much actually it has recovered. It is exactly like a ductility test, but we will cut the material at 15 centimeters. So we expect that the minimum 70% recovery is expected in the elastomeric modification of the binders. So if you see IS 15462, this is the code for the polymer modified binders test. If you do for crumb rubber modified, it is IS 17079. But if you specifically talk about polymer modified binders, it is IS 15462. So we perform softening point test as usual and elastic recovery at 15 degrees. This is to understand the recovery property, and the flash point test to understand the safety features, and the viscosity at 150 degrees. And this G star by sin delta, minimum 1 kilopascal should be there for unaged binder, and 2.2 kilopascals is for RTFO aged or shorter aged binder. And the maximum phase angle, because we wanted to limit the maximum phase angle, because let us say if we take the phase angle from 0 to 90 degrees, lower the phase angle, which implies that it is more elastic in nature. If the binder is more elastic in nature, when the load is applied, it can actually recover, it cannot have more plastic strain. If the phase angle is more, that means binder is very viscous in nature. So when the load is applied, it will have more plastic strain. So we do not want the phase angle to be more. We have to limit that maximum value at somewhere. So that is what the maximum phase angle, we have a limit. And frost breaking point, this is to understand the lower temperature property and the loss in mass. So when we are performing this RTFO, which is rolling thin film movement, to understand the short term aging properties. So when I fill this bottle and do the short term aging for 85 minutes, in RTFO. So before keeping this bottle into the RTFO, we have to take the weight, and after removing this bottle from the RTFO, if we take the weight, there will be a loss in some mass. That can be understood here from this experiment. And in addition to that, non-recoverable creep compliance at 3.2 kilopascals and also JNR difference. These two we obtained from multiple stress creep recovery test. So this JNR should be always low. JNR is nothing but strain by stress. Why it should be low? Because we wanted our material to have lesser strains always. So lesser the JNR, better it is. And JNR difference. Let us say if I have JNR at 0.1 kilopascals, so if I have JNR at 0.1 kilopascals, and if I have JNR at 3.2 kilopascals, that means when I apply a stress of 3.2 kilopascal, there must be some strain. When I apply a load at 0.1 kilopascals, there must be some strain epsilon 2. So let us say if the JNR difference is more, that means there is a more stress sensitivity. So when I keep changing the stress from 0.1 to 3.2 kilopascal, the response of the material is changing widely, which implies the stress sensitivity. So this JNR difference is used to understand the stress sensitivity of the binder. We do not want our material to have more stress sensitivity. So today if a vehicle carrying a stress of 0.1 kilopascal, and later if a vehicle carries a stress of 3.2 kilopascal, pavement should not behave too differently. So we should always have lesser susceptibility to the temperature and also the lesser susceptibility to the stress also. And another parameter is G star into sine delta. This is a fatigue related parameter. So that is about the modified bitumens. So let us say every time when we wanted to do any test, what do? We initially heat the bitumen, because at room temperature or intermediate temperature like 25 degrees, bitumen is having the properties of viscoelastic in nature, and it is stiff, it is hard. So in order to make it more workable, we need to heat that bitumen. So there are four ways to reduce the viscosity. We are always heating the bitumen to reduce the viscosity. So one way is to heat it, and another way is to mix it with the solvents. So if I have a bitumen and if I add some solvent, let us say this solvent is going to dissolve this bitumen into small particles. So the bigger bitumen will have higher viscosity. So as the size decreases, we can say that the viscosity will be reduced. Okay. So we use some solvents, thereby the bitumen sizes are particles will be size will be reduced, thereby viscosity can be reduced. Why do we need to reduce the viscosity? Finally our aim is we are going to add this bitumen with the aggregate, so that this bitumen will go and completely coat the aggregate surface. And another way is emulsify it. So if you could have seen this, the higher size of bitumen which is very stiff, I am going to convert into small sizes by adding some solvents. Let us say I do not want to add any solvent, because of adding this solvent, let us say there are some disadvantages. So what are those? We will discuss. So rather than adding the solvents, I wanted to take this bitumen and I wanted to put this bitumen into a mill, let us say colloidal mill. So I apply a rapid shear rate. So when we apply some shear rate, what happens? This entire bitumen will be broken into small pieces. So that process is emulsification. We will discuss about this in the upcoming slides. So emulsification is another process to reduce the viscosity of the bitumen. And there is another process called foaming of the bitumen. So let us say if we have a bitumen of volume V1, so I wanted to modify this bitumen in such a way that this volume I wanted to increase temporarily to V2. So what will happen if I increase the volume of the bitumen? Let us say I can add some chemicals and make the volume to more. So if there is more amount of bituminous volume is available, then if you have aggregates, these aggregates can be coated very quickly. But we are not going to discuss about foamed bitumen, but let us discuss about this. Mixing it with solvents is nothing but the cutback bitumen. Emulsifying it is nothing but the emulsion. So if we talk about the emulsion, so emulsion is a colloidal system. As I have already discussed, there is a bitumen. We put this bitumen into the colloidal mill. So then small bitumen particles will be formed and this will be suspended in a water. So this is a colloidal system where oil in water. That means let us say this bitumen is called as oil and this is in water. So this is dispersed in the water. So this is called as oil in water form. So this bitumen emulsion droplets usually of the size 0.1 to 10 micrometers and this is held in suspension in the water. So let us say I have used this colloidal mill and I made into the small particles and that is dispersed in water. So how can I confirmly say that these particles again will not come closer? So there should be some external force that would be keeping these small bituminous particles to stay like this. Otherwise what happens if you provide some particular amount of time, these small bituminous particles again will come close to each other and they will again become into the single very stiff bituminous mass. So in order to keep this suspended small globules or particles, we need to provide some external energy. This external energy usually is provided using emulsifiers. So we need some external emulsifiers are also called as some surfactants or some stabilizers. There are so many other external agents using which we need to maintain those bituminous small particles keeping away from each other. We do not want them to be collided for particular amount of time until they go and coat on the surface of the aggregates. Okay. So these surfactants, what do they actually do? So let us say now I have the bitumen small particles. I have removed them from the colloidal mill. So these particles after particular plus water is there. So I do not want them to be close. So what can we do? We can do one thing, that is, let us say if all these bitumen particles have positive charge surrounding and if this also has some positive charge, if this also has some positive charge, that means if I impart some charge onto the surface of each bitumen particles, what happens? Now these two bitumen particles will repel each other. So they will not come close to each other. So how do we impart this charge onto the surface of the bitumen? For that we use what do we call as emulsifiers or surfactants. So let us say there is some surfactant or emulsifier. So I have added that. So that has created some positive charge on the surface of the bitumen particles. If they provide positive charge on the surface of the bitumen particles, those are called as cationic emulsions. That means this emulsion has the charge of positive in nature. This is because of the positive charge imparted from the emulsifier. In the same way, if I use an emulsifier that can provide a negative charge onto the surface of the bituminous particles, that is called as anionic emulsion. So if you could see here, so this is our bitumen. So on the bitumen, you can see there is a structure like this. So this is the head of the emulsifier. This is the tail of the emulsifier. So this tail actually embedded into this bitumen, if you could see, and the head is placed on the top surface. Now if you see all the bitumen is having positive on the surface, thereby these two will be repelled from each other. And this medium is actually water. So emulsifier is the most important constituents of bitumen in water, and this emulsifier actually if you see this is a water medium. That means this emulsifier whatever is there also present in the water, so it should not repel from the water again. So this is like both water loving and also the bitumen loving, so it should be embedded into the bitumen and also should be suspended in the water. So what does the head and tail will do? So head is having some positive charge which is nothing but the polar portion. We call it as ionic portion because head is going to give some ionic charge to the bitumen, and the tail is having long hydrocarbon chain, and this chain is bound to the bitumen, that means that is entered into the bitumen. So the main purpose of this emulsifier is it prevents the coalescence of the droplets. So the small droplets, it will make us to be stay away. It will not make them to come closer, and also influences the setting rate and adhesion. So what is the setting rate and adhesion? Let us say I am saying that I have the bigger bitumen mass and I made into small pieces, and now on the top of that I also have some positive charge so that these small pieces will be staying apart. But if these small pieces are staying apart and when the aggregate comes into contact, here the main purpose is this aggregate surface should be coated with the bitumen. But how does this bitumen will go and coat on the aggregates? Because currently this emulsion has small bituminous particles and also the water. So yet somehow we need to make this water to be evaporated. What happens when the water is evaporated? We will have only the small bituminous particles. In addition to that, on the surface there is still the cationic charge. As long as this emulsifier is still staying on the surface of the bituminous particles, they are still away from each other. But we want all of them to be together to coat the to coat the aggregate particles. So this process is called setting. So this water should be evaporated, and once after the water is evaporated, when the aggregate comes into contact, this top surface positive charge also should be removed. Then only bitumen should be available. So when there is no cationic charge on the surface, what happens? Now all the bitumen will come close together and it will be like a single bitumen. So when the aggregate is there, it will come and coat the aggregate. So this setting, which is nothing but the evaporation of water and also this removal of charge, which is called as setting. And addition is nothing but this bitumen going and coating the aggregates. So these two, setting rate and addition, depends upon the emulsifier. So the setting rate and addition is influenced by the emulsifier. So here is whatever I have discussed. So at higher revolutions per minute in the colloidal mill, first we will be rotated the bitumen. So the hot bitumen, whatever is around 100 to 140 degrees, and initially itself the base bitumen, which is unmodified bitumen, we try to maintain its viscosity lesser, which is less than 0.2 pascal second. Then water is added and simultaneously in the colloidal mill where high shearing forces breaks the bitumen into small globules. So when this heated bitumen, one side we will be adding water and from one side you will be applying the higher shear rate. So in the presence of this, actually the bitumen will be broken into small pieces. So finally the temperature of the entire system would be around 90 degrees. So we will be adding emulsifier when simultaneously when the bitumen is broken into small pieces, we try to add the emulsifier, because as fast as possible when the bitumen is broken into small pieces, if I add the emulsifier, that will go and create the positive charge on the surface of these bituminous particles. So that will impart the electrostatic charges and that will prevent this again the coagulation of the bitumen. So let us say I have prepared some emulsion and somebody else have prepared some emulsion using the same process that has been mentioned. how somebody would be confirming their quality? So based on what properties? So these are the four properties based on which we can say that the emulsion whatever I have produced will be in workable condition in the field. So one is the stability. So what do we mean by stability? Let us say initially when I have prepared the emulsion, those small particles are staying apart, and on the surface of these particles the positive charge is there. Let us give half an hour, and that condition still should exist. It should not be that after half an hour or 15 minutes again everything will go back and again the base binder will come to the original state. So that is what called as stability. So this stability, for example, there should be a available time period until which this bitumen should go and completely coat the aggregate surface. Another is the viscosity. So we do not want the bitumen to be more viscous. That is our first priority. Here the main purpose of creating the emulsification is to reduce the viscosity of the bitumen. Thereby we can easily coat the aggregate particles without heating the bitumen to the higher temperatures. Usually there is another method which we generally follow is heating the bitumen to the higher temperatures. And another property is breaking. So the first task is to make this emulsification, but the main task is this bitumen at the end, small particles should go and completely coat the aggregates. For that, water should be evaporated, then the top surface positive charge also should be separated. This process is called breaking, and the last process is called adhesivity. So when water is evaporated, this bitumen should be completely coated on the surface of the aggregate. So to achieve this final adhesivity, we need to check with this initial three properties. So why does usually it will be having a stability problem? Because of the difference in the density. So whatever the emulsifier bitumen which you are producing, the base bitumen may settle owing to the difference in the density with the aqueous phase. So you are having water, in the water you have the bitumen particles. So bitumen has a different density and water has a different density. Because of the differences in density, they can get settled, and this settlement will cause coagulation. So we need to avoid that. So sometimes in order to avoid that, the aqueous phase, which is the water, let us say water is having the lesser specific gravity than the bitumen. So bitumen always wants to sink. So in order to increase the water specific gravity, researchers suggest to add calcium chloride so that a little amount of specific gravity of the water can be increased, and increasing this viscosity of the aqueous phase, and in addition to that reducing the size of the particles. Now we have small particles which are bitumen particles. With providing more time according to this terminal velocity concept, what happens, they will slowly come and settle at the bottom. So if the size is very large, it will settle very quickly. If the size is very small, because the weight and density will be small, it will settle slowly. If it settles slowly, what is advantage? Meanwhile, before it settles, it is still in the emulsification stage. As long as it is in the emulsification stage, if we bring the aggregates in contact, it will go and coat completely. So this is suggested that either we can reduce the size of the particles, otherwise we can increase the viscosity of the aqueous medium by adding calcium chloride. So this is regarding the stability. And regarding the viscosity, we have Sebald furol. So in this what we do is, so we try to take the emulsion and we try to pour that into a tube, and we see, and we try to allow that to fall. How much time it will take to fall, to collect that bitumen in the bottom? So if the bitumen is more viscous in nature, it will take more time to travel. So based upon the time it is taking, usually this viscosity can be understood. We do not want more viscosity. That is our main concern. And another important thing is breaking. Breaking is nothing but the loss of water from the emulsion. So how do we understand that the emulsion has already lost the water? Initially, when you mix this water and bituminous small particles, they are brown in color. So whenever this water gets evaporated, then it will be turned into the black. That means the breaking has been done. So this emulsion, when in contact with aggregate, so aggregate, we know it already has a charge. Let us see, if I am talking about the siliceous aggregates, what happens with siliceous aggregates? They have negative charge. So when the siliceous aggregates, when they come in contact with the bitumen particles, we know that already on the top of the bitumen there is some positive charge, and in addition to that there is some water. So this water has been evaporated now. So once the water is evaporated, we have remained with these bituminous particles with positive charge. So when these aggregates come in contact, so whatever the positive charge is there on the top of the small bituminous particles, they will be separated from the surface of the bituminous particles. Once they are separated, the only bituminous small particles, now they will come close together and they will coat the aggregate surface. So how fast or how much time it will take? Let us say, in order to remove this positive charge and also to remove this water from the emulsion, sometimes it may take a fraction of second, sometimes it may take more time. So if it finishes very quickly, we call that as rapid setting emulsion. This emulsion is being setting very quickly. And if it takes a little bit more time, that is called medium setting emulsion. And if it settles very slowly, that is called as slow setting emulsion, depending upon our purpose. Let us say, if you wanted to construct the pavement different layers very quickly, and let us say if you want to use this for tack coat, what do we do? Let us say you already have a base bituminous mixture you placed. Upon this, you wanted to again place binder course. These two are separate bituminous mixture courses only. So before even laying this binder course, so you wanted to apply a layer so that can provide a better contact between these two layers. Then you will actually spread the emulsion. So depending upon your purpose, if you use the rapid setting emulsion, then immediately it will be settled. That means you can immediately lay this next layer. If you use this row setting emulsion, you need to wait until this emulsion gets breaking, and that is, it will converted into the black. Then only you would be able to proceed for the further task. There are a lot of factors that will be affecting this breaking. The first thing is bitumen content. Let us say you have only 10 bituminous particles. Then they can be broken. That means their surface charge can be separated easily. The amount of water medium also could have been less. So the breaking will be taken place with lesser time. If the bitumen content is more, the amount of time taking will be more. And in addition to that, emulsifier type. What type of emulsifier you are using? Are you using the cationic type or anionic type? Because the phenomenon is different. And how much amount are you using? If you have more amount of emulsifier, it might take more amount of time. And the pH value and the particle size distribution, whether you are having the smaller particles or the bigger particles. If you use the bigger particles, they may settle very quickly. So based upon the environmental conditions, do you have the feasible conditions for the evaporation of the water or not? So let us say if it is very moist, then it might take more time for the evaporation of water. And use of braking agents. So are we using any external braking agent so that to progress this process? Based on all these factors, this braking would be influenced. So once the braking is done, we would be depending mainly on adhesivity. So depends upon whether you are using this on dry aggregate or wet aggregate, the adhesivity would be improved. Adhesivity is a function of type and amount of emulsifier again. So the same factors which actually affect there will also be affecting here the adhesivity. So what is the main uses? One is to use in the tack coat and prime coat. What is a prime coat? Let us say we have granular layer. So bottommost we have subgrade, which is nothing but the soil. We compacted this soil. Upon that I have granular layer. It can be multiple layers or single layers depending upon the purpose. So you have granulars. These are unbound materials. So upon this you are going to actually lay a bituminous layer. So we cannot directly apply a bituminous layer. What happens? This granular layer is exclusively a dry layer. Now it doesn't have any binder kind of bitumen. So before applying this bituminous layer onto the top, it is always suggested we will be spraying some prime coat. So let us say a kind of emulsion. Now emulsion is having very less viscous in nature. So what will happen when I apply the emulsion or very low viscous bitumen also can be used as this prime coat. What happens? That bitumen will slowly enter into the voids. So this will enter into the voids of the granular layer and that will fill whatever the voids present. If I don't apply this prime coat, what happens? If I directly place this bituminous mixture, whatever the bitumen present in that at higher temperatures mostly, that might be entered to down. So then you will not have the available bitumen here for the proper strength or performance. So and also in addition, in order to maintain the adhesivity or the contact between the two different, these are heterogeneous layers, right? One is a granular layer is a kind of unbound layer and bituminous mixture layer is a kind of binding layer. So this is always suggested to use a prime coat. So when we apply this prime coat, we want that bitumen or emulsion to move to the bottommost parts of the granular layer and to fill those existing voids. So if we want our emulsion to move to that much distance, our emulsion should have very low viscosity. It's like near to water. So that is the reason why mostly in prime coats and tack coats we use this emulsion. So tack coat is nothing but, so upon this granular layer, if you want to place this bituminous layer, whatever the layer in between, we call it as prime coat. Let us say now you already have a bituminous layer. Now upon this granular layer, I have one bituminous layer 1. So I do not want to lay all my bituminous layers into single thickness layer, let us say. This is a H1 thickness. Now I wanted to provide another bituminous layer with H2 thickness. Then, so when you want to place another bituminous layer on the existing bituminous layer, to have a better contact between these two layers, you are supposed to spray another layer that is called as tack coat. So either we can use the lowest viscosity binder at this place, otherwise we can use the emulsions. So emulsions can be used for tack coat or prime coat, and in addition to that for fog seal, let us say if you have any minor repairs and you wanted to fill those small openings, you can still use the emulsion, and the surface dressing at the topmost surface and micro surfacing and cold inflation plant recycling. Wherever we wanted to do the recycling, so in those places also, in this cold construction mostly if we do not want to increase the temperature, we can always go for emulsion. So in India, for anionic emulsions and cationic emulsions, we have an exclusively separate code books. IS 3117 for anionic emulsion and IS 8887 for cationic emulsion. Cationic emulsion is the most widely used type of emulsion. So there are three types of anionic emulsion: rapid setting, medium setting, and slow setting. And as far as the cationic emulsion is considered, there are 5 types of cationic emulsions. So let us say once we have already prepared the emulsion, so in the field if we wanted to understand that whether your prepared emulsion is in a workable condition or not, there is a crude field test. So you have, let us take 5 grams of the emulsion and mix with the 100 grams of coarse aggregates. Here the coarse aggregates of either 5 mm in size or 10 mm in size. So what is our main purpose? When I mix my aggregates with the emulsion, those emulsions should completely coat the aggregate surface. So if I have sufficient amount of time to coat the entire aggregate surface, that means I have produced the perfect emulsion. So in this 5 grams and 5 grams of emulsion and 100 grams of aggregate, if the mix can be made with 100% coating, that means it is medium setting or slow setting. So what happens in the medium setting and slow setting? In medium setting and slow setting, you will have a more amount of time for breaking these positive charges and also for the evaporation of water. Thereby, you will have sufficient amount of time for mixing the aggregate and coating the aggregates. If the emulsion breaks without coating, so let us say what is the problem if it breaks immediately? That means entire bitumen is coming into a single piece. That means viscosity is increasing. If the viscosity increases, you are not having the lower viscous material available to coat the aggregates. So we wanted the emulsion to be in the emulsification stage until it gets coated on the surface of the aggregate. Once after coating on the surface of the aggregate, it is okay to break. So in the rapid setting emulsion, the main problem is it immediately breaks. So we might get the sufficient time for the coating on the aggregate surface or we might not. So let us say if the 100% coating is done, that means it is either medium setting or slow setting. So if either it can be medium or slow setting. In order to identify whether it is either medium or slow setting, let us take the 5 grams of the emulsion. Now let us take 100 grams of stone dust. What happens? Stone dust is having very smaller in size. It's like a powder. So if I wanted entire this powder to be coated with bitumen, I need to have more amount of time. My emulsion should break very slowly. So until unless that is a slow setting emulsion, you cannot see the dust completely being coated with the bitumen. So if our 100 grams of stone dust gets coated completely, then we can say it as slow setting. Otherwise, we can tell it as medium setting. So this anionic emulsion is not much widely used. You can see here rapid setting, medium setting, slow setting. There are only three types. Mostly this rapid setting used for tack coats as we have already discussed and the surface treatments. Let us come to the cationic emulsion. Yes, the cationic emulsions mostly of five types. You can see rapid setting emulsion grade 1, RS1, which is specially recommended for tack coat applications. Tack coat is nothing but upon existing bituminous mixture layer, if you wanted to place another bituminous mixture layer. And rapid setting 2, this grade actually recommended for surface dressing works. If you have already existing surface and you wanted to lay another layer. The medium setting, that means as you move from top, now it will take more time for breaking. Okay, this is also for surface dressing and mostly this slow setting one is used let us say for this repair works, crack sealing, prime coat applications, because we need to have more time here. Let us say if I am going to use on prime coat applications, that means I need to provide the emulsion more time to go and penetrate into the granular layer gaps and fill those voids. So we need to use this slow setting. If I use the rapid setting in this application, what happens? By the time it go and enters into the voids of the granular layer, it will automatically break. When I say it breaks means water is evaporated on the surface of the small bituminous particles, the charge has been gone. Then what happens? Immediately entire bitumen will come to close. Then it will become very stiff. The viscosity is very high. As the viscosity is very high, it will not be moved to the downwards. So slow setting 1 and 2, these are actually used for this long time required repair works. So in addition to the emulsions, the another kind of bitumen is the cutback. This we have discussed in the starting of the presentation where in order to reduce the viscosity of the bitumen, one of the way is we can add some solvents. So we can add the solvents. By adding the solvents, what happens? Now the bitumen is there. I have added some solvents. What is the purpose of solvent? these solvents will dissolve the bitumen into liquid state. So now I will have a liquid bitumen. So in this liquid bitumen, solvent plus bitumen in liquid stage is present. So because now the viscosity is very less, now if the aggregate comes in contact, because its viscosity is very less, it will coat the aggregate easily. So after coating, what happens, or during the coating, whatever the solvent that is present, actually that solvent has to be evaporated. Only bitumen is available for coating the aggregates. So where does this solvent usually go? It has to go to the environment. So we are not separately collecting this solvent. These solvents are like gasoline or naphtha. What are these? These are the byproducts of fractional distillation of petroleum. So if we remember, in the petroleum, so when it is subjected to the higher pressures and temperature, so whatever the amount in this petroleum with lesser boiling point, they used to evaporate quickly. So in this process, gasoline and naphtha are one of the fractional distillation products. So rapid curing, that means in the bitumen and solvent, immediately if the solvent evaporates quickly, those are called as rapid curing cutback bitumen. And if they take some time, they are called as bitumen curing, medium curing. So if we use the naphtha or gasoline as the solvents, we call that as rapid curing. These are also used for tack coat applications or surface dressing. And in addition to that, in the medium curing, kerosene is used because of having medium volatility. So they can be used for prime coat or other applications. And in the slow curing, so it takes a lot of time to evaporate, like gas oils and some other diesels. So when we compare this emulsion and cutbacks, so the one of the disadvantage in the cutbacks is the volatiles. Those solvents have a negative environmental effect, and they need higher energy products are lost. So here, whatever you are adding, let us say this diesel, they are having higher energy, right? So they are, at the end, what we are doing, they are simply getting evaporated. That means we are losing the higher energy. And in addition to that, volatiles have low flash points. Let us say if you are using the diesel, what happens? When it is come in contact with the fire, there is a higher chance that it can be having safety issues. So in comparison to the cutback, if you take the emulsions, they can be applied at lower temperature conditions and also on damp pavements. So the most advantage of emulsion is you don't need to go for the higher temperatures like other process, and also there is no environmental effects. So as we understood now the type of the bitumens, especially the modified bitumens, emulsions and cutbacks, let us briefly discuss about the bituminous mixtures. So mixture is nothing but a combination of bitumen, aggregate, and we try to heat both of them and mix, we produce the bituminous mixture. So before producing this bituminous mixture, we need to test the bitumen separately, and we have to qualify that yes, this is a quality bitumen, it satisfies all the properties according to the IS 73 2013. In addition to that, we need to test the bitumens. These are called preliminary aggregate test. Once these two are confirmed, then we will go and prepare the bituminous mixture. Once after preparing the bituminous mixture, we will again create the specimens using this mixture. Then we subject this mixture to the particular loading conditions. Those loading conditions are the test conditions corresponding to the conditions which we are going to experience in the field or pavement. If this specimen is able to take all those test conditions and the failure conditions, then we certify that yes, this bituminous mixture is capable of taking all vehicular loads. So this production usually we perform in the laboratory first, and same can be executed or try to replicate in the field. So in the laboratory, when we are going to compact this mixture, whatever is produced, one kind of compaction we use impact, where in martial equipment we try to take the hammer and apply the 75 blows, and we provide some energy and we try to compact this specimen of 100 by 63.5 millimeters in size. Okay, and we also apply gyratory. This is not an impact load. So in this gyratory we try to shear the material and we try to compress or press the material, and we always indicate that this gyratory compaction is the most field representative compaction. And another is the kneading action. In the kneading action we try to press the metal to forward and backward, and this is not widely used in the current days. So these mixes should be similar to the field mixes, that is one of the criteria. And the level of compaction whatever we are applying. So let us say I have prepared a specimen like this. In this now you have bitumen, aggregate, and plus some voids are there. So I have applied some 75 blows. So what does this 75 blows of load application on the specimen indicates is, I have laid a pavement initially, now year 0. So initially the traffic is allowed here. What happens after 2 years? Whatever the air voids present in this bituminous mixture, they will be reduced because the vehicular loads are coming and they are further compacting. So after particular, initially let us say there are around 7% of air voids. After few years it can be 5%. Then again after few years it will be 4%. So after particular years of compaction are subjecting to the field vehicular loads, the density of the pavement comes to a stable state. Let us say we assume that as 4%. So when the bituminous pavement is having a air voids of 4%, that is after particular number of years, then that is a state where the bituminous mixture can take the rutting and also fatigue. So we try to produce the mixes in the laboratory corresponding to this 4%. To be general, 3 to 5% in range. So to be specific, 4%. So whatever the mixtures we are producing are corresponding to that. The mix that is produced. So now for this mix, whatever the specimen is there, we analyze that mix. What is the weight of that mix? What is the volume of that mix? What is the specific gravity of that mix? So whether this sample can take rutting or not, whether it can be resistant to fatigue or not. So all these volumetric analysis and performance analysis will be performed on this specimen. Based on that, we determine. So if I add this much amount of bitumen, now my specimen can be resistant to rutting, fatigue and any other moisture damage. So that bitumen content is what we call as optimum bitumen content. So if you could see here, this is the Marshall compactor. So where we apply, this is the hammer. So we will lift this to this height and we will leave. So inside this your loose mix will be there. And this is the gyratory compactor there with 1.25 degrees of angle. So here your specimen is mix is here there here. So this will be compacted. So that is the production of mix in the laboratory. Let us say if we want to produce a mix in the field, because that is our final aim. So what happens? There are two types of production of mixes in the field. One is the drum mix and also the batch mix. So in both the mixes, the general procedure followed is, initially we need to have the set of aggregates stored at some place. Let us say these are the cold feed bins. What is the purpose of these bins? So in each bin there will be particular amount of aggregate that is being stored. So once these bins are having aggregates, now I wanted to produce a mix. So from these bins the material will be moved to the downwards, and all that material will be collected onto this conveyor belt. So this conveyor belt will take this aggregates and that will be moved into this, you can see here, a drum. So what does this drum do? In the drum, whatever the aggregates that are coming from these bins will be dried. That means there must be some existing moisture inside the aggregate. So we do not know the past history. So we will be drying those aggregates. Once those aggregates are collected, those aggregates have been dried. So we already have the asphalt storage separately. We don't need to worry about that. So these aggregates which are dried, they will be taken to the a elevated place where the aggregate will be separated according to the sizes. There will be some screens. So using those like sieves, we have manually we use the sieves. Here you will be having the screens. So these aggregates will be separated according to the weights. So we know, let us say 13.2 mm. How many grams of 13.2 mm should be added? How many grams of 9.5? So from the screens, the particular designated amount will be added. Then the bitumen will be added and will be mixed. So the place where all this mixing is happening is called as plug mix or plug mill. Okay, that is the place this bitumen will be mixed. So if you are immediately taking that mix to the field, if you want to lay immediately, that will be collected in the trucks. If not, that will be stored in the silos. So these are the storage tanks that will be used to store the bituminous mixtures. So whatever the bitumen that I am going to use to produce this bituminous mixture, they should be providing a cohesion to the mix. So the main property of the binder here is it provides the cohesion. And also the temperature susceptibility of the bitumen is here important. Let us say if its softening point is particular degrees, and if you keep heating beyond that, what happens? It tries to flow. So the temperature susceptibility properties of bitumen, its viscoelastic properties. When I say viscoelastic properties, its behavior at various temperatures and its aging. Let us say before mixing, the bitumen is not aged. After mixing and when we have transported from the plant to the field, so during this time what happens? Short term aging will be done. So these properties, the properties of bitumens might change before bringing that to the field and also before heating. So how far this aging would be affecting the performance of the bitumen and the PG grading of the system. So these properties should be understood in earlier before doing the mix design. And as far as aggregates are concerned, the main purpose of these aggregates is to provide the shear strength. So if you take the aggregates, when a vehicular load is coming from the top, most of the load is being taken by the aggregates. Aggregates are the main building blocks. So this is because of the shear strength. If all the aggregates are interlocked with each other and they have better shear strength, and whatever the shear stresses coming from the top due to the vehicular loads, if those shear stresses are lesser than the shear strength of the aggregate, then nothing will happen to the pavement. If whatever the shear stresses that are coming from the top are more than the shear strength of the aggregates, then they will be completely slipped out of the order. So aggregates would be providing the shear strength. Binder is just keeping the aggregates intact. So they are acting as a binding agents. So we always want the shear strength of the aggregates to be more than the shear stress that is being produced from the vehicular loading. So this good interlocking is the mainly important. So once if we have the proper aggregates and also the good binder, this mix, the aggregate and binder mix should able to resist vertical compressive stresses. So if we have a pavement, when a vehicular load is coming from the top, main thing is the vertical compressive stress. There will be a compression coming from the top. That is one thing. Another thing is, as you keep applying the loads, what happens? This bituminous pavement may try to bend like this. So what happens if it tries to bend? Because this happens due to the repeated application of loads, because as the length of the bituminous layer is more, as you keep applying the top loads, it may try to bend. What happens when it tries to bend? After particular amount of loading cycles, it will try to bend. Then at the bottom you can see there must be a crack developed. This is because of the tensile stresses produced at the bottom. So our bitumen should not be very brittle, so that immediately when the load is applied it will bend and crack at the bottom. So this cracking is what actually from the bottom it will progress towards the top, and whatever the cracks that we are seeing on the top, if at all they are because of this bending crack, those are called as the bottom up cracking or fatigue cracking. If the bitumen is having good elastic properties, it will not break. It may bend, but after the removal of the load, it will come to the normal position. That is the purpose of modified binders, to be specific. So our bitumen should be, this bituminous mixture should able to take the vertical compressive stresses. If the vertical compressive stresses will not be taken, what happens? There will be a depression, which is nothing but the permanent deformation or rutting. So the shear stresses and tensile stresses at the bottom of the HMA layer. The main purpose of the mix is to take these stresses. And so permanent deformation, fatigue cracking and temperature cracking. So if you take the pavement, this fatigue cracking will be along the pavement. But at some places you will see in the transverse direction there will be some cracks. These are due to the lower temperatures, or which are nothing but the temperature, low temperature cracking. So if I talk about the resistance due to the permanent deformation, when you have a repeated load repetitions, this is not due to the single load applications, there will be a plastic strain. So when the plastic strain is being developed, and if the aggregates internal friction, especially this internal friction is due to the aggregate properties like shape, surface texture, gradation of the aggregates. If they are proper, if they are sufficient, you will not see this failure. And the role of the binder is very less, as we have already discussed. It provides this binding and also the stiff. Let us say when it is providing the bindingness between the aggregates, if the binder is very soft, what happens? It will flow. So it should be viscous enough to hold the aggregates, so that when the load is applied it will not undergo any permanent deformation. If we consider the fatigue resistance, the horizontal tensile strains at the bottom, as we have already discussed, and due to the repeated load applications, so this fatigue failure will happen. And also we understood that when I have a repeated load application, this pavement may try to bend if the thickness of the pavement or asphalt mixture is very small. Let us say if we have the thickness H2, if we have the thickness H1. So for H1 thickness mixture, there is a high probability of fatigue failure, because the thickness is less, it can bend easily, and the crack from bottom can be propagated to the top very easily. So wherever there is a insufficient thickness, there can be a possibility of fatigue resistance. And the air voids, what happens if there are more air voids? If there are aggregates in between, we suppose to have around 4% air voids. Higher the air voids, there will be exposure of these aggregates to the oxygen. So what happens if the aggregates are exposed to oxygen? When I say aggregates in the mixture, that means aggregates that are coated with the bitumen. Okay. So when this is exposed to the oxygen, this oxygen is due to the higher air voids, the air can circulate and it will be exposed to the oxygen. Then this bitumen will be aged more. What happens if the aggregate surface, whatever bitumen is, that is getting aged more, then bitumen will become very stiff. If the bitumen is very stiff, what happens? When the load is applied at the top, stiffer materials will tend to break easily. Let us say if we have a rubber, when you apply the load, it may bend, but it will not break. But if you take a stick and if you apply the load, what happens? It will immediately break. So we do not want our bitumen to be very stiff. That is the reason why bituminous rich mixes, the mixes which are having more bitumen, have the less susceptibility to the fatigue cracking. So higher the air voids, more will be the fatigue susceptibility. So we need to reduce the air voids in such a way that it should not be prone to more aging. And in addition to that, wherever possible, this thick well supported pavement will be having higher fatigue resistance. Okay. And low temperature crackings are especially due to the temperature susceptibility. So if you have a pavement and if suddenly if the temperature from higher to lower it has changed, then what happens, this pavement will become very stiff. When it is very stiff, we know again the same problem, which is a cracking problem. So in addition to this rutting and fatigue, the moisture sensitivity. So when the aggregate surface which is completely coated with the bitumen, when it comes in contact with the water, in addition to the traffic will always be there. In addition to the traffic, if it comes in contact with the water, so there is a high chance that the bitumen, whatever is there on the surface of the aggregates, can strip off. That is the reason why when we initially discussed about the preliminary tests on aggregates, we are supposed to perform the stripping test on the aggregate, and also we need to perform this moisture damage test on the bituminous mixtures before finalizing the optimum bitumen content. Okay. If we have sufficient binder, then it will not strip easily. If the coating of the aggregates is very light or very thin, then there is a higher chance that it can actually undergo to high sensitivity to the moisture. And if you have more air voids, what happens? There is a higher chance for the water to enter. So we need to make the mix impermeable. When I say impermeable, it doesn't mean that it should be completely zero in air voids. What happens if there is no air voids present? If it is completely dense. So in the summer, let us say, because pavement will not be subjected to single temperature or single moisture content in the entire year. We have multiple seasons. So in the summer, what happens? Higher temperatures around 60-70 degrees, then whatever the bitumen is there around the aggregate surface, it wants to expand because the temperature is increasing. But there is no sufficient space to expand because there is no air void. Then what happens? When the vehicle moved on the top of this aggregate mixture, whatever the bitumen that is there and whatever that has become very fluid now due to the higher temperatures, that will try to come to the top. That is the reason why on few pavements you see that at some places there is a black color patch, that is called as the bleeding of the bitumen. When we have insufficient amount of air voids in the bituminous mixture, bitumen during the summer seasons it will ooze out of the pavement structure, which is unavoidable if you don't have sufficient air voids. So we should not design for zero air voids. We should have minimum air voids, but at the same time they should not be too much. And if we have a better bonding between the aggregate and binder, as we have already studied the mineralogy of the aggregates, so when we have a proper bonding between the aggregates and binder, the exposure of this mixture to the water will not affect much. And the durability is, so when we subject this mixture to long aging, and also when we subject that to the water conditioning, and when the aggregates are subjected to the stripping, still how far it could able to maintain its performance, that is what durability. So either by increasing the film thickness or reducing the air voids or increasing the compaction, these are the few of the ways we can improve the durability. So these are all the structural related issues, and another is the functional. So when the user is using the pavement, so any kind of discomfort is a failure. Skid resistance is also a kind of safety issue, especially during the rainy seasons when water comes in contact. So when we actually construct a pavement, it inbuilt has some resistance or friction. So when a vehicle moves on the surface of the pavement, because of the friction between the tires and the pavement, it will not slip easily. In rainy season, what happens? There will be a water film that is placed on the surface of the bituminous pavement. Whenever water comes in the contact between the vehicular tires and also between the pavement, what happens? The friction will be reduced. Thereby the vehicular movement will be slipped towards the sides. That is the reason why whenever we test the pavement for the skid resistance, we need to test the pavement in the presence of water. So when we already apply, we spray the water on the surface and then we allow the vehicle to move on that, then we determine the roughness of the pavement. So that is the worst condition we'll face. So if it could able to maintain that performance in satisfactory condition, then we can say that our pavement is very good with skid resistance. And also in addition to that, we try to use a rough textured aggregates and also those aggregates which are resistant to polishing. So we have performed one experiment in the previous lectures, polishing stone value, to understand the how quickly an aggregate can be polished or can become very smooth in nature. So we have to avoid that. That depends again also on the mineralogy of the aggregate. So by using the rough textured and polishing resistant aggregate, we can avoid that. So once after that, the main workability, which is nothing but this is a user when he is preparing the mixtures, he doesn't want to use more energy to mix the aggregate and mixture. As we have discussed this previously, angular aggregates they demand more amount of energy to mix with the bitumen. But the main advantage of angular aggregates is they can provide the better interlocking. So rounded aggregates usually provide better workability. We can actually work very easily with the rounded aggregates. But the disadvantage is they cannot have better interlocking. So we cannot completely use the rounded aggregates, but at the same time we need to make sure that the easiness in mixing the asphalt mixtures and also aggregate gradation. So this gradation is nothing but the choosing different sizes of aggregate fractions. We will not mostly depend upon the workable mix, because if we want to provide more workable mix, there is a higher chance that that mix can be prone to more permanent deformation or rutting. So we always give the priority to the performance than this workability. So finally, what is the outcome we expect from a mixture or bituminous mixture to be used in the field? It should have a sufficient binder. If it has a sufficient binder, that means sufficient coating will be there. Thereby, whatever the performance today we are seeing in the bituminous mixture, even after 5, 6 years or 10 years also, if we have sufficient coated aggregates are available, then its durability can be maintained, and sufficient stability and flexibility to satisfy the need of the traffic. So when the loads are coming, it should not easily bend, it should not easily get compacted. It should be stable, stiff and flexible. When I say flexible, that means when you remove the load, it should again come into the original position. The more flexible it is, that means more fatigue resistant it is. And it should have sufficient air voids for secondary compaction and thermal expansion of binder. So during the summers, if binder wants to expand, it should have sufficient air voids and maximum void content to limit permeability. So we should not have higher void content because moisture damage should be avoided. And also higher the void content, what happens? Higher the aging of the aggregate surface, which will again leads to the fatigue damage. Sufficient workability, which is not a prominent, but workability should be maintained. And finally, skid resistance for safety of the users. So in order to satisfy all these conditions, if I add particular amount of binder, let us say 5.5% of the bitumen by weight of the aggregate mixture, that will not satisfy. Otherwise, let us say only VG30 or modified binder, one type of binder cannot satisfy all these properties, cannot maximize it, to be frank. So higher durability, higher flexibility, higher workability, all these things cannot be achieved at a time, but these properties can be optimized. That means minimum this much resistance of rutting should be there, minimum this much resistance of fatigue. So optimization can be done. So what are that binder type, what is that binder content, using which we can actually obtain this optimum characterization is what? our main concern in the mixed design. So to summarize, so we test the binders, we test the aggregates for preliminary confirmation. Then this aggregates and binder will be mixed at particular temperature. For this, we use the mixing compaction temperature for binder. Then we prepare the bituminous mixes. Once the bituminous mixes are prepared, we calculate all the volumetrics, its weight, volume, what are the amount of voids present inside, what is the specific gravity. If all of them are meeting according to the MOTH standards, then we use that binder content as OBC. Using that OBC, we will again cast and check what are the existing air voids. We will confirm. Then we will perform some test on this for moisture damage. And at the end, if it satisfies all these performance related testing, then we finalize that binder content as the optimum binder content. So when I say about volumetrics, we will be discussing about this in the upcoming weeks. So this for the asphalt mixture specimen 100 by 63.5, this is a Marshall specimen. So once after preparing, we already know initially the specific gravity of aggregates. Then we calculate the loose mix we prepare, and we calculate the specific gravity of that loose mix, which is called as GMM, theoretical specific gravity. And for this mixture, compacted mixture also, we will calculate the specific gravity, that is called as bulk specific gravity. So using these values, we can calculate what are the amount of air voids. You can discuss about this in the upcoming GMM minus GMB by GMM. So how to calculate all these air voids and that we will discuss in the upcoming lectures. And what are the voids in this mineral aggregates, what is the effective specific gravity, what is the amount of binder that is observed. Let us say I have added 5.5 percentage of binder to the mixtures. In this, maybe 1 percentage of binder could have been absorbed by the aggregates. Only 4.5 is available in between the aggregate particles for binding the aggregates. So how to calculate this binder absorption? And if we wanted to understand at what temperature we have to mix, we already know this equiviscous method for unmodified binders. So we test the binder at 135 degrees, 165 degrees. We determine the viscosity corresponding to 135 and viscosity corresponding to 165, 135 and 165. Then we will plot a graph. Then, so y-axis you can see the viscosity. So on y-axis 0.17 plus or minus 0.02 Pascal second. What is the temperature corresponding to this viscosity and what is the temperature corresponding to this viscosity? These two temperatures we will calculate. These temperatures are called as mixing and compaction temperatures. But this process is not recommended by the Asphalt Institute for modified binders, because most of the times when we have followed this process for modified binders, what we observed was their mixing and compaction temperatures are coming more than 175 degrees. So at this much higher temperatures, what happens? Whatever the polymers that are presented in the modified binders, they may get degraded. And another thing is, in most of the times at these temperatures also, few modified binders, or let us say at 150 degrees or so, modified binders are still at non-Newtonian behavior they are showing. So when I perform this equiviscous method for unmodified binders, one of our assumption is that bitumen behaves in Newtonian range. That means their viscosity is independent of shear rate. So if I perform the viscosity test with particular RPM, revolutions per minute, whatever the viscosity I am observing, that should be same if somebody else performs with another shear rate. That means viscosity is independent of shear rate. But when we observe this for modified binders couldn't able to follow this trend. Thereby, this equiviscous method was not recommended for modified binders. So one is either manufacturer who is providing the bitumen, they can actually specify the mixing and compaction temperature. If not, there are two methods which we will quickly discuss in 2-3 minutes. One is DSR phase angle method, another is DSR steady shear flow method. So the main concept of this phase angle method is We know that when the phase angle is 0 degrees to 90 degrees, at 90 degrees, bitumen behaves as viscous. When I say viscous, that means bitumen behaves like a liquid. So we want the bitumen to be in this liquid state so that it can coat the aggregate properly. So whenever the phase angle value is near to 90 degrees, the code suggests when the phase angle is 86 degrees in specific. Whenever the phase angle value is 86 degrees, then we can assume that bitumen is in viscous or liquid phase, so that temperature can be used. The temperature at which phase angle is 86 degrees, that temperature can be used to mix. So in order to find out this phase angle 86 degrees, so that method is called as phase angle method. This we perform using dynamic shear rheometer. So we take the bituminous binder, we subject this binder to 0.1 radians per second to 100 radians per second. So I will be rotating my spindle on this bituminous, then you will find out the phase angle. All this data can be obtained from the results and complex modulus, all the data will come. So you will only collect the phase angle and you perform this test at multiple temperatures. So if you have data at multiple temperature, you can actually plot a master curve. Your phase angle and the reduced frequency, you can plot a master curve. So from that master curve, you can determine when you are actually getting the phase angle of 86 degrees. So you will be having some frequency. Let us say 86 degrees is here. So you take the corresponding frequency. So you bring this frequency here and substitute here in the omega place, you will get the mixing temperature. And in the same way, if we substitute here, you will get the compaction temperature. So this is the most reliable method for modified binders, especially polymer modified binders. And another process is the steady shear flow procedure. So in this procedure, what we will be doing is, we take this bitumen and we subject this bitumen to shear stresses. Okay, so shear stresses starting from 0. So let us say till 500, you keep applying the shear stresses onto the bitumen. So what we observe is, initially there will be higher viscosity. If you keep on applying the stress, if you keep on increasing the stress, we will observe that the viscosity will be reduced. It will be reduced. After particular shear stress, you can see the viscosity will become constant. So let us say at 1000 pascals, we understand that the viscosity has stabilized. So we perform this test for, let us say, multiple temperatures. So temperature T1, temperature 2 to T3. So I got viscosity 1, viscosity 2, viscosity 3. This is for temperature 1, temperature 2, temperature 3. So then what I will do is, I will again plot viscosity versus temperature. So if you have viscosity versus temperature, what can we do? So corresponding to 0.1 second plus or minus 0.02 pascals. So whatever is the temperature that you can take, and also here it is not 28 pascals for according to this method, 0.35 plus or minus 0.2 pascals. So corresponding to these two, you will determine the temperatures, and those temperatures are corresponding to mixing and compaction temperature. So this is a summary. We know that first we need to do the gradations. So after gradations, we will heat the aggregate and binder. Then we will keep 2 hours for conditioning. During the conditioning, what happens? Whatever the bitumen that is coated on the surface of the aggregate, that will be absorbed by the aggregate. So this is the correct process. So after keeping for 2 hour conditioning, then if the bitumen or if the aggregates having water absorption is more than 2%, then we have to keep the aggregates for 4 hours conditioning. If the water absorption is less than 2%, 2 hours conditioning is enough. Then we will take that mixture, we try to compact that mixture either using gyratory or Marshall compactor. See, this is a loose mix. We calculate the theoretical specific gravity, and this is a compacted mix. We calculate the bulk specific gravity. Weight of the mix is common in both the calculations, but the volume, if you take the loose mix, In the loose mix, you take only the weight of the individual particles. We do not take any voids in between. But if you take this specimen, we also consider the voids also. That is the reason why this is voidless and this is with voids. Okay. Let us see few questions. We'll quickly see the questions. Which of the following can act as a cross-linking agent in the polymer modified bitumen? So we know that it is sulfur. What is the purpose of this cross-linking agent? This sulfur, it will react with the bitumen. Then after that, yes, it is sulfur. So yeah, let us say around SBS modified polymer, it will form a covering and then it will make the dispersion stable. Second question, the maximum phase angle permissible for polymer modified bitumen as per IS is. So I told that we need to limit the phase angle value, but I did not tell how much to limit. Any idea? Maximum how much we should limit? If the maximum is 90, then it will go into the viscous phase. So we do not want our phase angle to be very high. We have to limit that so that elastic properties in the modified bitumen still will be there. So here that would be 75 degrees according to the code. So we test the phase angle, and if the phase angle always should be 75 degrees. The tail of an emulsifier consists of. So we know that head is a polar group. Okay, it will give the charge. Molecules containing oxygen is wrong. Amine group wrong. So tail consists of long chain hydrocarbons. During the manufacturing process of emulsion, the viscosity of the asphalt binder should be. I told that initially before adding the water and emulsifier, we need to heat the bitumen to around 100 to 140 degrees. So that 100 to 140 degrees actually is corresponding to viscosity of 0.2 Pascal second. So we need to maintain the base binder's viscosity less than this. Then we will be trying to add the emulsifier. Which type of emulsion is recommended for tack coat applications? Any idea? We know that either it could be RS2 or 1. Yes, RS1. RS1 is the recommended. Which of the following solvent can be used to prepare the rapid curing cutback? Rapid curing means solvent should be evaporated quickly. Kerosene we know medium because it will take some time to evaporate. So rapid means quickly it should. So diesel also slow we know. So naphtha is the one which will be evaporated very quickly. The durability of bituminous mixture can be increased by. So if I want to increase the durability, what are the options? Reducing the bitumen content. What will happen if I reduce the bitumen content? There will not be proper coating. So this is wrong. Increasing the volume of aggregate. No, even if you increase the volume of aggregate, what will happen? Strength may improve, but the durability will not. Increasing the bitumen film thickness. Yes, C is correct answer. So if you increase the thickness, durability will be increased. Fatigue susceptibility of bituminous mixture can be reduced by. So if I want to increase the fatigue resistance, so reducing the air voids. Yes, this is correct. Let us see, is there any other? Increasing the air voids, wrong. If increase the air voids, aging will be increased. Using siliceous aggregates. No, using type of aggregates will not have any improvement. Using higher pillar, no. So if you reduce the air voids, what happens? You can reduce the susceptibility. Aggregates from cold feeder bins are transferred to drying drum using. So we know that We store the aggregates in the feeder bins. Then from this, using the conveyor belts, usually we transfer the aggregates to the drying drums. The effective specific gravity of aggregates cannot be measured because we know we can determine the bulk specific gravity and apparent specific gravity, but cannot determine the effective specific gravity. The reason is, in all the specific gravity is weight by volume, assuming the density of water is 1. Okay, weight by volume. Everywhere we take weight as the weight of the aggregates, but the volume, when it comes to the effective specific gravity, if we have an aggregate, so these are the voids, some amount will be bitumen will be entered into the voids. There will be remaining amount, there is no bitumen entered. So if we want to take the volume of the aggregate surface, including the bitumen absorption, because we cannot practically calculate or measure the amount of absorption. Theoretically we can. So in the laboratory we cannot calculate the amount of binder that is penetrated into the each aggregate. That is the reason why we cannot calculate the effective specific gravity. But using other specific gravity values, we can calculate the effective specific gravity. So here the question is, it cannot be measured because bitumen absorption of aggregates cannot be measured. Conditioning of loose mixture at the compaction temperature before the compaction is important because, so we condition the bituminous mixture because we wanted to allow for the bitumen absorption. If I prepare the bituminous mixture and immediately if I compact, I am not giving a sufficient time for the aggregates to absorb the bitumen. That is the reason why we need to give the 2 hours of conditioning period. Okay. This is regarding today's live session. Are there any other questions? Yes, sir. You can unmute and ask.
Madam,
Sir.
while solving the assignment, I am stuck up with one question.
Hmm.
So, we are adding the elastomer for what purpose? For the storage stability or for phase angle?
If we add the elastomer, elasticity will be increased. Elasticity is increased means phase angle will decrease. That is the
Okay.
indication. So phase
Uh-huh.
angle less than 45, that range, that means that is elastic in nature. So if we
Uh.
add the elastomer, that implies that elasticity is being reduced.
Because we have to restrict that phase angle to certain limit only, na?
Yeah,
That
75
means to
degrees.
reduce the, so we can say that means to reduce the phase angle, the elastomer is required.
So as much as we reduce, that is beneficial only.
Yeah, yeah, yeah.
Hmm.
And one more is the we are using the sulfur as a cross-linking agent.
Yes, sir.
Okay. So it helps to improve the storage capacity,
Yes, because
storage stability.
when it added with the base binder, so it will make the polymer to disperse sufficiently. If you don't add that sulfur, the
Uh,
maltine fraction whatever is available and the asphaltene, their dispersion will be completely collapsed. So to maintain that stability in storage, we need to add that cross linking agent, sulfur.
okay. Okay. Thank you, madam. Thank you. Thank you.
Thank you, sir.
Is there any property difference between this track coat and prime coat?
Yes,
These are
sir.
both same material.
Both can be same material, but prime coat should have lesser viscosity than the tack coat because we want prime coat to percolate more into the granular layers. So tack coat can be a little bit viscous, but prime coat should be always very less viscous so that it can serve the purpose.
So you were, I was asking him, was asking about this question that addition of elastomer bitumen is expected to reduce,
Yes,
reduce.
it actually improves the elasticity. So how to quantify that? To quantify that, we have the test of determining the phase angle. So when you determine the phase angle, currently if the phase angle is 60 degrees for the binder, after adding the elastomer, that will actually reduce. So this is an indication that addition of the elastomer actually reduces the phase angle.
No, we are using elastomer to increase the property. The property phase, when phase angle increases, means at a higher temperature it is functional, means it is not reducing its properties. That is main purpose.
The purpose is to improve the elasticity. When we improve the elasticity, so it can actually increase the fatigue resistance. So when the load is applied, it will not suddenly break because now it is having elastic nature. So this actually can be quantified using the phase angle. When I say phase angle is less, that means it is more elastic. It can actually flexible like this. So if it is flexible, it is useful for both high temperature and intermediate.
Correct,
What?
correct, correct. I
Hmm.
got it.
So at higher temperatures, even if there is a permanent deformation, after the vehicle moves away, after a particular amount of time, it will come to the original position. So it is beneficial for the higher temperature resistance also. As far as the fatigue is concerned also, it may bend when the load is applied, but it will not be providing any crack at the bottom because it is not brittle now. It is elastic in nature.
Yes, yes. Thank you. Thank you.
Okay, then we'll close the meet. Thank you for
Yes,
joining.
yes. Thank you.